Exponential growth is actually compounding kind of things. You have heard about like the price was rising very slowly, and then suddenly after some years the price is going like this. The graph, if we'll draw the graph,
Yeah.
this kind of representation is not the exponential growth. Similarly, decay is there, means things going like first it was like moving like this, and then suddenly means after some time, initially the growth was very constant, but after some years the growth will be like this, means moving toward the infinity kind of things. Not exactly infinity, but a very sharp growth is there. So you have heard this term exponential growth in some kind of what we can say decay. You have learned in the like let's suppose a fossil fuel is there, so fossil fuel decay is there, right?
Yeah.
An exponential growth you have learned in what we can say in stock market. Have you ever seen? Have you ever heard this word growth? Growth, exponential growth? No.
Yeah.
Let's see. So we have some. So exponential growth. If we talk about the exponential growth, so like the bacterial growth, these are growing exponentially. Population increase. So exponential growth, population increase, or what we can say, money grow, money growth scheme, etc. Similarly, in decay, we have for the decay, we mostly learn the like food decay. If I will throw edible like food is there, then the food start decaying, and the decay in the food works on the exponential growth decay, exponential decay. We have some specific formula to represent this decays. Let's see. So the formula. The formulas of exponential growth and the decay are, so exponential growth is the formula will be fx equals to a1 plus r to the power of t, and exponential decay. In decay, the property gets reduces, means size gets reduces. So that's the formula will be changed only by the sign, means here it will become 1 minus r raised to the power of t, where r is rate of growth, rate of growth, and t is the time, and a, you know that that's the initial value. If you can relate this formula, you know that's amount in compounding annually, the amount equals to, you have seen this formula, p times of 1 over r is the power of n. So p, principal, rate, and then time is the same thing here. So fx equals to a 1 plus r to the power of t. Similarly, for decay, it will be a 1 minus r to the power of t. That's very similar to the compound interest formula. Okay. So you can keep in mind just. So R will be the rate of growth. Let's suppose this state there's a statement like there's a inflation of 5%. 5% is increasing every year. The inflation is increasing 5% every year. So rate means 5%. This time, let's suppose the price of any article is 600. So A will be my 600. After 3 years, what will be the price? So time is my 3 years. Okay. I hope the basic concept is clear to you.
Yeah.
Uh,
Yeah.
Now, the value of R. Let's see. Exponential growth, you can see a value R here. The R value lies between 0 and 1. The R is something which lies between 0 and 1.
Yeah.
So if we'll see this, so here 1 plus R, the term 1 plus R in the bracket can be taken as growth factor. So if someone will ask you what is the growth factor, so 1 plus R. T is the time steps, which is the number of time the growth period is to be multiplied. Similarly, 1 minus R is the, what we can say, exponential decay growth factor for the decay case. Done?
Yeah. Yeah.
Now, this 1 minus R will also have the value less than 1. That's very obvious. So here 1 minus R is less than 1. Of course, it should be less than 1. Less than 1. Now, most of the time the forms will be the exponential forms. So the most common different form or formula for the exponential growth is the very first one is the function will be written in this way: a, b, and some power is there, or a1 plus r to the power t. This is the most common, but sometimes you can see this exponent. Exponential means you know that exponent is there. Exponent is there. For example, x. So a, b, and x can be there this form, or the question will be in this form, or the last form is my will be kind of this p naught e k t. Similarly, for the decay, we will have the fx equals to a, b, and then negative x will be there, or fx equals to a1 minus r to the power of t, and the last p would be my p naught e minus k of t. P naught is the initial, here this P naught is my initial quantity, nothing else, principal, initial
Okay.
quantity. Now, for the exponential growth, B equals to 1 plus R equals to e to the power of k, and for exponential decode. See, some things, some points are there, some like the equations are there that we will have to keep in mind. Okay, then there is no other way. So 1 plus R we will consider as e to the power of k, and similarly for exponential decay, the b equals to 1 minus R is equals to e to the power of minus k. So nothing else. This 1 minus R is considered as e to the power of minus k, and here 1 plus R is considered as e to the power of k. That's the just different representation of exponential and the decay, exponential and decay. Just look at the formula and the, of course, some different forms of the exponential growth or exponential decay. And let's now use the question to practice. Now, if you have the calculator, side of the calculator, please take it. because I don't have this scientific calculator, so you will have to do some calculations there. Shall we start?
Yeah.
Do you have the scientific calculator? Of course.
Is graphing calculator fine?
Sorry.
I have graphing calculators, I find.
Oh, nice. So I'll give you some equations to you, and then please, I need those answers. Like, I'll give you the points and then use your calculator to get the answer, please. Question will be, what is the amount received? This will be like totally like similar to the compound interest. So let's suppose I have the, what is the amount from investment? This is my, see, exponential growth money scheme. So I'm talking about the money growth first. What is the amount received from the investment funds after 2 years if dollar, let's suppose 100,000 were invested at the compounded rate of 5% per every quarter. So what is the amount received from the investment of fund after 2 years? Means time is given as 2 years. This is my 100,000 principal is given, which is the initial stage, which is my A. That's my $100,000. Now rate is given. This is my year. So how many quarters will be there? Division by 4. So we will get 0.05 per quarter. Okay, how much we'll get? Oh, so 0.5. Okay, hold on. Oh, I'm so sorry. In 2 years, how many quarters will be there?
8.
8 quarters, sorry. Yes. So 2 times of 4, which is going to be 8 quarters. Now the rate. So if rate of percent rate is 5%. So rate is 5%. This is my per year. But I need quarterly. So this will become 5 over. We have 5% per year. So, so rate percent will become how much? Let me see if it's given us. So invested 5% per quarter. No, per quarter is already given, not per year. As per the equation, per quarter is given. Now let's find out the final amount after 2 years. So now, so we know that fx equals to a1 plus r to the power of d. So use $100,000, 1 plus, that's my 5%, which is my 0.05. 0.05, it will calculate this. This 5% is my 5 over 100. It is 0.05. Rest about t means 8 here. So a is 100,000. 1 plus r. R is my how much? So rate, that was my 0.05, and t is given as 8 quarters. So this is my. Now use your calculator and let me know the answer. So fx equals to just 100,000 and 1.05 to the power of 8. And if we calculate this, we will get 14774.544. Means after, so 100,000 will become 147,000 745.44 in 8 quarters means 2 years. So there will be an increase of $47,745 in the money in 2 years with the rate of this one. Check this if it's clear or not.
Yes, sir.
That's the exponential thing. Means the amount will become this much in 2 years. So if we'll see the like approximate value, so you will get therefore you see an amount of 147745 approximately is received. It's received after period of 2 years. Means all the values will be given to you. You will have to just put all the values in this formula, a times of 1 over r to the power of t, and then once you put the all values there, use the calculator and you will get the perfect answer. Okay, just have a look, then let me know if any queries there.